So let's talk about this. Rules that we already know that we didn't know we knew. Like, what is x times x times x times x? What is it?
X to the fourth.
X to the fourth. X to the fourth. Why is it x to the fourth? Because how many x's are there? 4 x's, right? That's what we were taught, right? We were taught, oh, okay, it's x to the fourth because there's 4 of them. We've been doing that, right? We've been doing that with our 2's and our 3's and our, remember with prime factorization? We've been going, oh, we prime factorize it out. And then oh, there's 3 3's, so it's 3 to the third. Or there's 4 5's, so it's 5 to the fourth, right? And so with this, we're like, hey, there's 4 x's. It's x to the fourth. But why? And the reason is that each x is x to the 1. So, if it's x to the 1 times x to the 1 times x to the 1 times x to the 1, it actually equals x to the 1 plus 1 plus 1 plus 1, which equals x to the fourth. And so what we were doing without knowing it is we were adding the exponents. And we have a rule for that. X to the a times x to the b equals x to the a plus b. And what we say there is, remember Tuesday I said it and I said it and I said it, and I kept trying to say it so you would remember it. But I thought it was on tape, but it wasn't. So we'll try it again. When I multiply 2 powers with the same base, I add exponents. Remember that? When I multiply powers that have the same base, I add exponents. Okay? That is so crucial. So, now, if I give you this problem, x cubed times x squared times x to the 5th, what is it? X to the 10th. It's x to the 3 plus 2 plus 5, which equals x to the 10th. Good. Let me give you a harder one. X to the 4th times x to the 5th times x. That one's a little harder. X to the 10.
Still a 1 there.
Yeah, there's still a 1. There's still a 1 there, so you have x to the 4 plus 5 plus 1 equals x to the 10. Good. Alright, I'm going to get a little harder on you. A little harder. X to the 4 times x to the 3 times y squared. Now what is it?
X to the 7th y squared?
Yes. So you remembered. See, the other day you didn't remember, and you tried to put the x's and y's together, and you have to remember this isn't a smoothie. We can't put bananas and apples together. Bananas and apples are separate. They have to stay separate. So the x's are like. So because they are the same base, I can add their exponents. X to the 4 plus 3. But because the y is not like, it's still times y squared. So it equals x to the 7th times y squared. Or you can actually just have no, sorry, no x to the 7th y squared. Good? Alright, let's step it up a notch. X to the 4th times x to the negative 5. What does that equal?
1 over x.
1 over x. Yes. Because you're saying x to the 4th plus a negative 5, which equals x to the negative 1, which we already learned x to the negative 1 is 1 over x, so that's 1 over x. Okay? So that one is good, but it brings in something. It brings in something. And that something is going to be able to be covered in this section. So, something is when we add negative numbers, what are we doing?
Subtract.
We're subtracting. When you add negative numbers, a positive plus a negative, you're actually subtracting. Now when you add two negative numbers, you're adding, right? So two numbers, when you add two numbers with the same sign, you add them. It doesn't matter if it's negative 2 plus negative 3, you still add it, negative 5. Okay, two numbers with the same sign. How about 3 plus 2? Okay, it's 5.
But it's negative 5, isn't it?
Oh, it's just 3 plus 2. So these ones are the same sign. These ones are the same sign, and that's negative 5. I do have a negative there. I don't know. Okay, but what happens when I take two numbers with different signs? 7 plus negative 5. Or 5 plus negative 7. Okay, those, when I'm adding two different signs, then what I really am doing is I'm subtracting, right?
But keep the sign of the bigger one.
And you keep the sign of the bigger numbers. So, this one is the plus, that one's a plus, right? I'm going to subtract them, 5 from 7, and get 2, and keep the sign of the bigger number. So it's just 2. This one I'm going to subtract them 5 from 7, and I get 2. But I keep the sign of the bigger number, and it's negative 2. Okay? So when we add a positive with a negative, we're subtracting. Two different signs. This is key. It's crucial I'm teaching you this because next chapter we're going to use it a lot to make the hardest chapter in the book easier. Okay? So I know this might seem mundane, but believe me, learning this and understanding that when we have two signs that are different, we are finding the difference. When we have two signs that are the same, we're finding the sum, or we're adding them. Here we're subtracting them, here we're adding them. But what does that have to do with this? Well, we just said, when we're finding the sum that are the same, we add. But when they're different, we subtract. What's another way to write this? Isn't this just x to the 4th times 1 over x to the 5th? So wouldn't that equal x to the 4th over x to the 5th? Oh, wait a minute. We're dividing. And when you divide the powers with the same base, we do what? We subtract. So it equals x to the 4 minus 5, which still equals x to the minus 1, which still equals 1 over x. But we have a new rule. And that rule is x to the a divided by x to the b is equal to x to the a minus b. And that hopefully was covered in 15 minutes. Yes, it was. Okay. Okay? So important. So important. That rule, I know it's easy to memorize the rules. It's hard to understand them. Okay? It's easy for me to just throw up here when I take two powers, the same base, and I'm multiplying them, I add the exponents. But when I'm dividing them, I subtract the exponents. Sure, I can say that. You can write it down. You can have it in your notes. You can follow the rule. The hard part comes in understanding the rule. Why is it happening? Why? Why did this occur? Because we're adding a negative to a positive. We're really subtracting. So that led us, mathematicians, into creating a rule. Like Luke tried to do earlier with the, wait a minute, there were 6 letters and there's 6 numbers and they were all even, and is there a pattern? See, mathematical mind. He's putting patterns and trying to figure out, if it's a pattern, I can make a law. I can do this every time. It doesn't matter at what level you're at, believe me. You can create a law that nobody ever else seen. I did it. It's what took me from believing that I was like just a dumb jock into believing that I was this is an oxymoron, but a dumb genius. You know? All of a sudden I went from being this dumb jock to calculus teachers like, you're a genius. This is like ridiculous what you just did. In 1 hour, you know, my whole life changed. And I went from being this, I just want to look for a job with money, to I want to educate students. It just, whole life changes. And don't ever let yourself not, you know, pursued whatever it is that you like to pursue. You know, you see patterns, use it. You know, don't ever limit yourself. Believe me, I limited myself for years.